Okay, so hi everyone. I think we are live now. So, very good morning to all of you. I'm Shubham Gupta, a senior engineer application and support for Altum Technologies. I welcome you all in this today's session on the discovery. We will see what are the possibilities within your F123 series 3D printer. So most of you already know what F123 series printer is. So just for an brief, F123 series 3D printer is basically a Stratasys office friendly FDM based 3D printer, right? So in today's session, basically, I'll not go into what 3D printing is or why 3D printing or how it works, what is FDM. Not on those topics. Basically, I'll just give you a brief introduction of our F123 series range of printer, and then we'll see the current offerings from Stratasys for that particular 3D printer series. I'll show the current material available with all those machines, and I'll show you the comparison between each and every material, and also we'll see the upgradation process of the materials within your machine. Meanwhile, if you have any question during this session, you can just type your question in the chat box. We'll go to the answers at the last, right? This is the first look of uh, basically F123 series machine. F123 series machines, under F123 series there are three machines. Like one is F170, the second one is 270, third one is 370, right? So all three machines by look wise is exactly similar. You can see over here, if anybody has 170, it looks like similar, or 370 as well, right? The major difference between all those three machines is the first one is the bed size, second one is the material capability, right? So like we have a size range of starting from 10 by 10 by 10 in 170, which goes up to 14 10 14 in 370 machine. So this is basically the timeline of this machine. Stratasys has launched this in 2017 with the brand name of Stratasys F123 series 3D printer, under which 170 was there, 270 was there, and 370 was there, right? And then, like in 2018, just next year, they have launched a new material, which is a TPU. TPU is we generally know TPU is an elastomeric based 3D printer material, right? So it has some flexibility, right, in the properties side. So this material is basically available on all series range, be it 170, 270, and 370. And in 2019, they have put some advanced features in the toolpath software. Toolpath software means the software which generally is helpful to give a command from system to the machine, right? So we have a software here in GrabCAD Print. So they have put some advanced features in that particular software. And in 2020, they launched two new materials. First one was Tiran, which is basically a nylon family based 3D printer material, and the other one was the ESD safe material. It's a blend of ABS and the conductive properties, right? And in this year 2021, they launched a material called carbon fiber. Again, it's a blend with ABS, and it's a highly stiff material, stronger as well compared to ABS. We'll see the details of these materials in coming slide. So this is basically a timeline for this machine. And what I mean to say over here is every year, Stratasys is putting effort to bring innovation to your footstep, right? So each and every year, either they are launching a new materials for the machines, and or on the software side, they are putting upgrades so that user can use it at the fullest, right? So what are the core features of this machine? Basically, I have segregated into six different categories. A few are on the software side and a few are on the hardware side. So first core feature was our printing software, which is a GrabCAD print software. It's an open software, and the key capabilities of this software is you can directly import a full assembly file within this software, and even with this machine you can print that full assembly in a single go. So how is possible? Like generally we have seen for any 3D printing software, first we have to design our we have to design it in some native CAD software, and then we have to export it in an STL, and then 3D printing software is capable to import that STL file. But in CapCut print software, we know basically it can import a direct CAD file. What that means is you have designed it in CATIA, you have designed it in SolidWorks or any other NX Pro software. So you can basically directly import that particular design file or an assembly file into the GrabCAD print software and give a direct command. Right. This is a printer software capability. Second one is a mobile application. All F123 series machine comes with a mobile application, both available for Android as well as iOS. So with that particular application, you can access the machine at any location. Whatever it is printing in that particular machine, you can see it on your mobile screen, and you can see all the notifications regarding the consumption, the time and the material, and how much material has left now in the machine. And if there is an issue within your particular machine, that particular notification is also you can see on through mobile application. Right. Second feature was the mobile application. Third one is the machine software itself. You can see over here, it comes with a touch screen with which user can operate this machine. Right. So generally like everyone has used the Android phones or iOS, so the interface is kind of similar within this machine, so that you can directly click on that particular tab on that icon, and you can do the settings, calibrations, each and everything you can do with the help of this touchscreen. So machine software is a core feature of this machine. Fourth one, on the hardware side, we have basically a print head. Print head designs are very unique for this particular machine. Each and every material comes with a specific print head, so that there should be a no problem on the blocking side. Generally, we have seen that FDM printing nozzles get blocked while swapping the materials or by using, right. But in F123 series machine, each and every material having different properties is comes with a different print head, so that there is no challenge with the nozzle blockage and all, right. Other parameter was the material. We have 8 different engineering materials, thermoplastic materials within this series. I'll cover it in coming slides. What are the different materials and how basically each and every material is different from the other one, right. So fifth capability is on the material side. Sixth one is our support and services, which comes under this machine, that I'll show you in coming slide. So as discussed, printing software, it is a GrabCAD print software. The current version is 1.58. Basically, each and every month, Stratasys is giving upgrade in the printing software, with which you can generate a more complex tool path, and you can do advanced set the advanced parameters while printing. You can see over here, this is a single printed part, but with a multiple density. What that means is, where you need a much force, you can put different parameter during the printing setting, and where the force requirement is less, that load is less, so you can save your material and time for that particular geometry, right. These all possibilities I have shown in one of our previous webinar, which was the like on the Stratasys GrabCAD print. So if somebody has missed that webinar, you can check on our YouTube channel, and you can watch the recording session of that, right. So other thing was on the material side. So with F170 and 270, there are a total of 5 materials which are now available in 2021. So ABS, CSA, PLA was a very common material during its launch. After that, they have launched TPU and carbon fiber, which can be used in 170 machine and 270 machine, right? As well as we have other materials of Diran, which is a nylon-based polycarbonate blend with ABS, and ESD blend with ABS. It comes with the F370 machine. So somebody has F370 can use now 8 different materials, model materials, right, depending upon the properties required. As well as we have a special material on the support side as well, which is a QSR. It's a complete water soluble material. Like once we have 3D print our part, this QSR will support you to print the overhang and like overhang geometries, and later on like we have to dip it into a tank with of water, and this QSR will get dissolved. So this is a water soluble support removal automatic solution for the post processing activities, right. This material is available on all the series. So till now you have a basic idea of like F170, 270 comes with a 5 material option and 370 comes with an 8 material option, right? So what on the hardware side, like I told you, a printhead is unique. So printhead, regarding printhead, we have a set of four combinations of printhead. First one is a standard printhead is comes in a black color. Everyone must have seen this printhead. Whenever someone will purchase a new machine, they'll get this printhead, right? So this printhead can be used for ABS, ASA, carbon fiber, EST, DRAN, and QSL. So anybody has this printhead can be used for these six different materials, right? So if somebody want to use elastomer, we have a special head called blue, like elastomeric head. It's blue in color, which is used for a TPU92 material, right? Similarly, for PLA, since PLA works on a very less temperature as compared to ABS, so for that there is a special head with a cooling module, so that the material will get flow properly through the nozzles, right? So for that we have a head which is in gray color, and it can be used for the PLA material. Then on the last we have a special head for carbon fiber as well. Like you can use a standard head as well, but since it's a carbon filled material, so it's an abrasive in nature, so we have a special head which is in green color and can be used for carbon fiber. So as I told, the tar print head is very unique in design. So you can see over here, it basically assembled on the machine with the two combinations. One is there is a lock on the left hand side connecting with the pipe and one cable. So with this you can basically assemble it, disassemble it in a 2 minutes, and you can swap the head as per your requirement, right? This is on the print head side. Now, so far, now you have a basic idea of what are the materials available in your machine which you have, or what are on the software side, what are the different parameters, right? So now we'll focus on the material and the material properties, and we'll do a quick comparison between all those. So ABS, starting from ABS, because ABS is a very common material, and everyone who has a 3D printer, be it any 3D printer, they must know the ABS, right? Because it's a very common material in 3D printing industry. ABS is a very good material, having good mechanical properties, and can be used for a functional prototyping. We all know like jigs and fixtures application, because it's a very high dimensional. It provides a high dimensional stability, so that like it can be used for functional applications as well, right? Anybody has a concept idea in their mind, they can basically use to print any complex geometry with that ABS material. These are few of the properties mentioned over there. And in F123 series, it basically comes in a 9 different color option, right? So mostly we have used ivory, but if somebody has a color requirement, they can basically choose different color depending upon the specific application, right? So what is the alternative of this material? I saw most of the customers are stick into a ABS material only, right? So maybe they don't know the properties of the other material. So that is a key focus for today's discussion. What are the alternative of ABS which they can use for their applications, right? The second alternative is the ASA material. ASA is basically again having a same color range which ABS has, with an additional of a light gray color option. So there are a total of 10 different color options are available within ASA. Okay, no issues for that. What else? Like Stratasys has recognized this thing that ASA comes with a matching or exceeding a mechanical properties if they compare it with the ABS material, right? So you can see over here the ultimate tensile strength, isoid impact, and the elongation at break. All three values are higher side if we compare to the ABS, right? This is one of the key properties of this ASA material if we compare it with the ABS. Okay, now somebody will say, I don't need a color, I'm okay with the ivory, okay with the ABS material, like not since the mechanical properties are almost similar, why will switch to ASA, right? So we have a second parameter which is specifically for ASA is a UV stability. So generally whenever I went for installation or any training session, I generally tell ki ASA is a UV stable material. What that means is you can use it for an outdoor application, right? But I never shown him a practical example of using an ASA at the outdoor application, how ASA and ABS is different if they print us like a common part with both the material, and how it basically differs. So for this an example, like I have taken an example. This is kind of a bird house which is printed by one of our reseller globally, and what they have done is basically they have printed this same model in one in ABS and one in ASA, and they have fitted it at the outdoor, right, and a direct sunlight and all other weather conditions. So after a year or so, they have noticed that the part which is painted with an ABS material, the color gets changed into a yellowish shade, right, and the ABS, that the other side ASA which was on ivory, the color is still remain the same. So this is basically the application of UV stability. Whenever we have any part which is going to be used at the outdoor applications, that is the only reason we always recommend to use ASA as compared to ABS, because ASA has some UV stability properties with which the part will not get deteriorate once you are using it the outdoor or a direct sunlight applications or some other weather conditions, right. This is basically a practical example of I can say the comparison between the SC and the ABS material. What else if someone will say I don't need the UV stable part, like I have no application for the outdoor thing. So what else ASA differs from the ABS, on what other parameters these both materials are different. This is just an example printed with the ASA material. So the third property I can say which differs ASA from ABS is its infill style. What that means is, to basically explain this property, I have used a design file which is basically a dumbbell you can imagine, right. So one dumbbell was printed on ABS material and one dumbbell was printed on an ASA material, right. So I told you ASA has some enhanced mechanical properties if I'll compare it to the ABS material, right? So ASA basically, due to those enhanced mechanical properties, it allows for a longer bridging whenever you are using at a low infill density. What that means is, if you are printing at a double dense, or you are printing at a low dense, single dense, or high density. So those in like whenever you are using sparse parameter in your print software, so ASA will allows to print it as a longer bridging. With that, what will happen? Basically, you can see the ABS M30 sparks filled take around 1.11 kg of material, right? Similarly, on the other hand, the part which is printed with an ASA material weighs only 680 grams. So this is basically a big difference while we are using this parts density and we are using ABS material. So right, so this is a 63% material saving by weight if for this particular file if we are using ASA. Just for an clear understanding, I have import that file in graphic print software, and I took a double dense infill style over there. And on the second hand side, I use ABS material and with the same default setting of the double density infill style, right? So you can see the quick comparison over here. The default setting for ASA material infill density is 14%, right? Which can reduce up to 10% as well. On the other hand, this default setting for ABS M30 infill density is 36%, right? Which can be reduced up to 28%. This whole the result over here is if we are printing that file with ASA, the part printing time is somewhere around 17 hour, and it's a 60 cubic inches of material which is model material which is getting used, right. On the other hand, if you're using ABS, the printing time is somewhere around 31 hour, and model material consumption was 122. This is a huge difference. Because of enhanced mechanical properties, ASA gives you the longer bridging while generating a tool path, so that the material and time consumption would be less. So that is the reason we always recommend to use ASA as compared to ABS. There is a good option if we'll compare both materials, right? So what do you need to use this ASA material in your machine? If you have 170, 270, 370, you just need a spool of that particular material, because it can run on same head which is used by ABS, the black one, right? Standard print head. So you need a spool of ASA material and you can run it in your machine. So okay, so far we have basically discussed two materials, ABS and ASA, right? Third material which we are going to discuss is, you can just see a video. Wait a minute, I will just play one video. Yes. So this is basically an elastomer material from Stratasys, which is TPU92A. So it comes with the same support material QSR. You can see, you dip it into a tank of water, and the support material will get dissolved. So no labor work over there, right? Yeah. So now you have a basic understanding. Okay, TPU is something where we need an elastomeric property. We can basically use the TPU material. So TPU, thermoplastic polyurethane, this is common name for in a 3D printing industry. Whenever we say TPU, thermoplastic polyurethane. So 92A is what? 92 is basically a Shore value on a scale of it. Basically gives you an idea of flexibility that material offers, right? So whenever we have the application of where we need a soft touch or shock absorption or something like that, we can basically use TPU 92A material, right? And for this like to explain you better, some one of the Stratasys reseller globally has done a two test. First test was to check the strength while pulling a car by this particular material. Like, he has printed a chain link, and he tried to pull the Honda Civic with this 3D printed material. And second test was a lifting weight. I'll show you a video.
In beautiful sunny upstate New York, and we have hooked up a couple of cars. As you can see, we have a strap, but we have the connection between the strap.
So you can see this connection is made with the TPU material.
F123 using this TPU elastomer material. So we're going to see if this chain link is going to hold up this F-150 pulling this. What is it? It's a Civic.
It's a Honda. I'm moving. This was done by CAD Dimension company.
All right, so let's get a close-up look and see how it held up. Not only did it...
So you can see over here the pulling strength of that particular material, the stretch that material can bear. But you'll get an idea by seeing this video, right? So similarly, I have one more video with which that guy has shown the weight lifting capacity for that particular, again, that same chain link with printing on a TPU material. Yes.
All right. What's that another?
Yeah. So hopefully you get a good idea of what are the capabilities that you can basically, what are the possibilities of that particular material with which you can use it for a specific application. These are the few examples in the automotive industry where you can use this TPU material to print some of the parts which can be used for the prototyping and all. So if you are not getting an idea still, you can see this image, and you get a better idea. That cup holder, the pipes, hoses, ducting, all those stuff are getting 3D printed with the help of TPU material for that particular automotive application, right? So now this is an industrial example from Polaris. It's a global example. So what they have done is basically they have used TPU material to 3D print a customized locating fixture of the particular badge on the vehicle, and they have printed a cup holder prototyping and the intake duct as well, right? So basically initially they are using a metal fixture for locating that badge, and there are certain challenges while using that particular metal fixture, because that fixture itself can damage the paint on the final product while using it. So they need something which is a soft, which gives a soft touch while using, so that it will not damage the final product. So what they have done is they've used TPU92 material, and they have 3D printed a customized fixture for that particular locate that particular badge, and you can see the few images over there. This was the 3D printed TPU location, that fixture, right? This is example from Polaris. And now what do you need to make it work on your machine? If you have 170, 270, 370, be it any machine, you need an elastomer kit to run that particular material. So what are the things which includes in that elastomer kit? You'll get a spool of TPU material for sure. You will get a print head which was in blue color, right? So which can run TPU material. You will get a two machine components, basically, since it's a kind of rubber material. So those blocks would be helpful to feed that material into the machine. So you'll get in that particular two Y blocks, right? And you'll get a brochure with the installation instructions, and within that you'll get a link to download the latest software, the best practices of the document, that particular material, and the latest firmware which will able to run your machine this TPU material. So all these things comes in an elastomer kit. If you want to upgrade, like some machines was, the new machines already comes with this elastomer kit properties. This like the upgradation process is already there in that particular machine. If you have old machine, like you already has the machine in house, so what you can do, you can basically upgrade it with the elastomer kit, right? And you can able to access the TPU material within your machine. So fourth material is carbon fiber material, which I told you, ABS CF. It's a blend of ABS and carbon fiber, right? So let's see a video.
The new Stratasys ABS carbon fiber 10 material on the F123 series is a strong, stiff, and lightweight material. We can see the stiffness here in our spring demonstration. We have a blue
So you can see the
ABS
deflection over
spring
there.
and a
The ABS
black
is getting
ABS
more
carbon fiber
deflected.
spring, and our ABS spring is stretching farther than the ABS carbon fiber spring. ABS CF10 is a ready-to-use carbon fiber material that drops into our Stratasys F123 series printers. It prints reliably, repeatably, and accurately.
Right. So you have seen this video and you get an idea, like that lady has shown the two same springs, which was one was printed on ABS, second was on ABS carbon fiber, and shows the deflection by applying a weight on both of that particular springs, right? So ABS was getting more deflected. Why so? Because ABS CF has 50% more stiffer than standard ABS material, right? And it has like 10% of chopped carbon by weight within blended with the ABS, and it comes with the same QSR support material which is required for post processing. Like you can basically print with complex symmetries, overhangs with the carbon fiber. You dip your part in the tank, the support will get dissolved automatically, right? So ABS CF comes with all those properties, and again it is available on all the machines, be it 170, 270, 370. You can run CF on all the three machines, right? So again, these are the few parameters, like this slice height which is available was 7, 10, and 13 inches. Soluble support 15% stronger, 50% stiffer. These all things we have just discussed now, right? So this is again a one comparison video of ABS versus ABS CF. The black one on the right hand side is printed with ABS material, and the left hand side was printed on a carbon fiber. You just like play this video, you'll see. So the deflection you can see, basically ABS is getting more deflected. Against a quick comparison of both ABS and ABS CF printed on F370 machine, right? So this gives you a basic idea again. So the quality you can see over here, someone must have doubt that since it's a carbon fiber, the quality is not as good as ABS. So you can see the 7 slice height and the 10 slice height comparison, both are printed on ABS CF10 material, right? Again, few of the samples which are printed on CF10 material, you can see the comparison over there. Yes, so this is an industrial example from a BMW. Basically, again, what they have done is they have printed a fixture with ABS CF material. You can see the traditional fixture was like a traditionally manufactured fixture was with metal, and it was too bulky, you can see, and heavy as well due to the solid block of metal, right? So what they have done is basically they have optimized this fixture and put some ergonomics so that it is easy for the user to handle that particular fixture. And obviously it's a 3D printed plastic, thermoplastic material that ABS shape. It's a very lightweight, so that the user who is basically operating this one can lift it a couple of times a day without any body fatigue, right? So the weight reduction, improved ergonomics, and the less fatigue for that particular user, right? So you can see a CNC aluminum weight was around 16 kg, and the part which is printed with additive manufacturing, the weight was somewhere around 1.4 kg, and the lead time reduction as well, you can see from 18 to 1.5 day, right? This is a quick example where you can use carbon fiber material. So again, now what do you need to get it done? You need only a spool of material. So this one is recommended but optional. The printhead is optional. You can use your standard printhead as well, which comes with your machine, which is black in color, right? So the only thing which must need is the ABS carbon fiber spool. So you can take that spool and you are able to run that material in a particular machine, right? So this is the upgradation process of ABS CF. Now this is a new thing. It is ABS ESD7 material. So first thing is this material only available with F370 machine. So you must have F370 to run this material. What is this material all about? So basically, what are the properties and all? To get that information of ABS CST, basically you must have the clarity of these three definitions, which was conductive, insulative, and dissipative. All these three things we have basically learn in our school time, what is conductive materials, insulative materials, and also just for a brief, conductive means they have a free flow of electrons, right? So they can easily pass the charge throughout the body, right? That particular material. On the other hand, insulative is completely opposite to the conductive. They have a limit of flow of electrons and basically a high electric resistance. They not at all like pass the current from itself, right? Dissipative, on the other hand, is conductive, but basically they dissipate the charge to the ground very slowly, like means in a more controlled manner if we will compare it to the conductive material. So ESD is basically a natural phenomena, right? We must have heard that hair and comb example, that like we'll rub that comb with our hair and we'll place it near the paper or our skin, that you will feel some static charge over there, right? So this is a natural phenomena. Whenever we rub two bodies or two surfaces, the ESD, like the electrostatic charge, appears. And like this, even on a small scale, can destroy any electronic component or erase that particular media from the devices, or even on the higher end it may explode, cause the fire and explosion, right? So basically, if like it is a very small, that ESD event is very small, maybe it may not be noticeable or to the equipment and all, but on the repeated events it may damage the complete electronic component. So in an electronic industry where we are basically using the jigs and fixtures applications or some soldering applications, we need some material which can basically dissipate the charge to the ground in a more controlled manner. So that is the reason this ABS CSD materials comes into picture. So this ABS CSD, I told, runs only on a 370 machine. So basically carbon nanotubes are blended within this ABS, and it's a blend of material and can replace metal and plated fixtures in the electronics industry. Same characteristics as ABS, the mechanical, and it comes with the QSR soluble support material. So this is one of the example where you can use ABS EST material. You can see over there the jigs and fixtures. We have printed the design files with ABS EST material. So I have a video over here just to explain you better. So this is again an example where they have printed this fixture. Right, so let's say we have to test this particular board, or I can say you have to solder something. So you have printed the fixture of that particular uh, this devices, and with the ABS EST material, right? So what do you need to make it work? You need a spool again, EST material spool. Head is completely same, the standard head, which is you can we are basically using for ABS material. Use the same print head you can use for EST material, and your machine is ready to for production, right? So this is just for a quick upgradation process. You need a spool of material to run this ABS EST on your F370 machine. Now, the fifth material, it is basically a Digan. Digan is a nylon family-based 3D printing material. Again, it comes with F370 machine only. So F170 and 270 cannot run the Digan material. So if you have 370, you can use this Digan material. Digan is basically, again, I told you earlier, nylon-based thermoplastic FDM material. So mineral filled 7% by weight. That mean is due to this it offers a very less surface friction, right? So and it has very good toughness and impact strength. So again, for the like applications where you need a strength, a stiff body, or a tough tool, right? So you can basically use Digan material as compared to the ABS and other stuff, right? So you can see over there the toughness modulus is very high for Tigan if we compare to ABS, say polycarbonate something, right? The surface friction is very low, and ultimate tensile strength is also very high if we compare with ABS, or carbon fiber. So where you can use it for robotic end of arm tooling, for your prototyping or chemical resistance applications where you need something like that. Jigs and fixtures for production part where you need high strength tough material, you can basically use Tigan material to print your part. This is a quick video of Digan explaining you some of the key properties of this material, right? One thing is that Digan comes with a breakaway support. So QSL support is not applicable over here, but that support is very easy to remove. The guy will show you on the video as
Today
well.
we're talking about Duran. Duran is a nylon-based thermoplastic used in 3D printing. It's very durable and tough and resistant to hydrocarbon-based chemicals.
So you can see it comes with a black color. It's a dark gray, I can say.
For non-marring factory floor tooling, such as this end-of-arm tool.
This is an end-of-arm tooling example.
To pick and place parts without damaging them.
So you have load your material in that
Other
machine.
applications include jigs, fixtures, prototyping, and low-volume production of highly customized parts.
So this is one of the examples where you can use the Digan material.
Part you want to replace with Duran. It's usually made out of aluminum, which is very heavy, expensive.
Instead of aluminium, you can use Digan.
Part you're trying to inspect. Like most FDM materials, Duran can be painted, sanded, machined, and media blasted. Duran can be printed on the Stratasys F370, and it uses a breakaway support system called Sub 4000B. It also is printed on a high temperature build.
So for printing this material, you need a special tray as well, because it's a high temperature material. So standard tray will not work. So it comes with a separate tray.
Print with Duran are air hockey parts. I printed these 4 parts all in the same build tray, and it took about 20 hours to print. Overall, I was happy with how these printed. I printed them with a.
So you now see the breakaway support as well.
One thing to note about Duran is it is very moisture sensitive, so it's important to store it in a dry environment. However, the spool can be placed in the printer overnight to dry it out.
You
The
can see
material
it is
used
easily
has a bit
removable
of
from
moisture
the
in it,
tray,
which causes some
and
surface
this
heat.
support get also like you
Also,
can
Duran
easily
prints
take it
very
out.
hot, so be sure to wear gloves when handling the parts in the tray right out of the printer.
See, so this is straight out of the printer, and you can directly use it for your end use application. So they have printed a hockey set of
So here's
this
some
vector
footage of
table
us
of.
playing air hockey with these parts.
So you can see over here, because of very less surface friction, they are able to do this with the Decan material, right? So again, what do you need to run this Decan material in your F370? You need a spool of material, of model material, a spool of material of support as well, because it need a breakaway support, like QSR will not work with this material. And you need a special tray, which is a high temp build tray. So it comes with a transparency, like it's a transparency sheet, I can say. Instead of standard black build tray, it is somehow transparent, and with that you can able to run that particular Decan material on your F370 machine. Yes. So the other materials which we have is PCABS material. PCABS, we know it's a polycarbonate blend with an ABS material, right? And it's a widely used in the industrial thermoplastic. So anybody has 3D printer, you must know ABS, PC, those kind of material, right? So in F370 we have a material PCABS, and again the heat diffusion temperature is high for this particular material, and it is stronger than traditional ABS, right? So wherever you need some of the properties on the higher side of mechanical strength and all, you can basically use polycarbonate ABS material as well. So what do you need? You need only a spool of material to run it on F370. The print head is completely same which you already have for ABS, right? So this is an upgradation process of polycarbonate ABS material. The other one, the material is the PLA. The PLA, it's again a very common material. So PLA, ABS, all these are very common material. PLA is polylactic acid. We generally heard this term, right? It is very I can say cheap material if we compare the other materials of ABS, this Tiran, this carbon fiber, right? So for initial prototyping, let's say you have a concept idea in your mind and you want to print it in a like you need a physical part of that particular design, so you can use your PLA material. It's available on F170 to 7370, and with 10 to 11 different color options as well. So you can use this material, and you can basically do a quick ideation of your like you can bring your idea into reality with this particular material. So for schools or a classroom events where there are a lot of students and you are giving training to them, or somehow very draft idea in your mind and you need it to be a physical, so you can use this material. So PLA needs a spool of PLA and a specific printhead assembly. Each and every machine is already basically capable to run this PLA material, so you must have this head already. What you have to do is you have to install a model print head in place of a model head, and in place of a support head you have to install a cooling module. You can see over here in the image. So you have to assemble both two, and your machine is ready to run a PLA material. So this is a quick comparison of all the 8 materials which I have shown you. Basically, PLA is not there because PLA is just for an initial prototyping, right? So, the quick comparison of 7 materials. ESA compared to ABS, I shown you 3 properties: UV stability, enhanced mechanical properties, and the main one, the major application was on the infill side as well, because the weight reduction was very good if we compare ABS and ASA. PCABS for high impact strength and heat deflection temperature. You can use PCABS. EST specific application on the electronic component side. TPU specific application on the flexibility side. DRAN, again, a low surface friction is required or a good impact resistance you need. You can use Tiran material for an end tooling. Carbon fiber, high stiff to weight ratio, you get it with the carbon fiber material, so you can use it. And this carbon fiber is best, like gives you great properties for a jig set fixture application, right? So this is something new for, I believe, everyone. This is basically our service offering now from Stratasys. Due to COVID and all, we generally, it's not possible to travel, like, right. So what Stratasys has done is, Stratasys has this comes on this platform for all the customers. Basically, this is a Stratasys Academy platform. So in this platform, those who are the users of Stratasys machine, they can basically create an account through us on this platform, and you can able to access some of the videos on the maintenance activities, on the training activities as well. I'll just give you a quick demo of it. Like, once you search on Google and Stratasys Academy, you come across this link, academystratasys.com, academy.stratasys.com, right? So there, once you have a login ID of this particular platform, you can able to access the videos specifically related to your machine, and some of the general idea, like the concepts of what 3D printing is, what are the different materials, what are the different applications of 3D printing. Those kind of e-courses are available on this platform. Just for a quick introduction, like, let's say some new joinees there near industry, or in like, or some students are new, are using this your machines, and also they can access this platform, and they can go through this course content, and they can basically gain the knowledge. So for making this account, you just write it to me, that I'll share my contact details at the end. So you just write the machine information, what you have, and the email address for the registration, and it's completely free. We'll pass on the information to Stratasys, and you'll get an notification from Stratasys Academy portal. So this is a very good initiative. So I request everyone who has this Stratasys machine, they can basically use this concept, right? So thank you so much for this today's webinar. I hope you get a basic idea of what are the different possibilities now within your machine, be it any, like, 170, 270, or 370. 170 has a 5 material options, but you can use it for high-end applications as well with the carbon fiber material, right? You have a TPU material there, ASA material there, right? If somebody has 370, they have a PC ABS material, they have a DRAM material, they have a ESD material. So on the software side, both machines are same, right? So based upon your application, if you still have some doubt, you can ask me on the chat. I'll just quickly go through the chat as well. Or if you have some projects which you want to do with us, like, so let's say you have a 170 but you need a ESD material, you need a DRAM material, or somehow, or you don't have a material but you have a project to do, you can reach out to me on this email address, shubham.gupta@item. So basically, you can text me, or you can call me on that number as well. We'll sit and we'll discuss on your project, and we have a couple of machines in our Bangalore offices, and we'll basically get your part ready with the specific requirement. So you can be in touch with us. So let me just quickly go through the chat section as well. I believe there is no question. Yeah. So thank you for joining once again. Thank you so much. So we'll continue this series, and for upcoming webinars, you'll get a notification from our team, right? So thank you so much.